one here we have a swimming teams, and we have a coach with four swimmers. Okay, so for this we have four swimmers, and we need to identify as each swimmers. The coach here will just record the time it takes for each swimmer to finish one of the swimming style here, either butterfly, backstroke or freestyle, and all of the times recorded for each swimmer are provided as summarized in this table over here. So for example, here in this for this record, top actually spend like 38 seconds for you to finish the butterfly stroke, etc. Okay, so this is actually the summary of the times it takes for each of the swimmers to finish the stroke here. And in order to prepare for competition, the coach here has to choose which swimmer will be in charge of each stroke, because it's just the relay team. So after one swimmer finish one of the stroke here, the other swimmer will start other strokes. Okay, so each of the swimmer here will have to be in charge of one of the stroke here, and one person will only be in charge of only one stroke. So there's another requirement for this. So basically, this activity asks you to choose what is the best swimmer for each stroke in order to provide us with the best result. So the question here asks you for the assignment of the stroke to each swimmer who will be in charge of each stroke in order to have the minimum time. Remember that this is a competition, so we want to finish the competition in the shortest time. So we want to minimize the problem here. The objective here is to minimize the times it takes for all of the four swimmers here to finish all the four strokes, and each person will be in charge of one. Okay, so that is the idea about this. Now the solution is actually given here for question 1. For question 2 you have to do it yourself, but for question 1 we have already give you the solution here. But I suppose that it's best to have a look at the solution here for only for activity number 1. For the remaining activity number 2 and 3, we suggest that because in your exams you will be given the problem only without a solution. So it will be best if you just have a look, read the questions carefully here and try to do it on your own. Okay, just for practice for the final exams. Now let's just do question 1 first. So I have already summarized put the table in this. And just put our table in here. We have the input section, which is actually our table given in the question. And now here's the name of the swimmer. And now we need to define the season and the constraint here. So for this one, just simply select this whole table over here, and we do it here. So basically, the idea here is that we need to decide who will be in charge of which stroke. So first of all, I just put 0 here. Okay. Because currently we need Excel to decide first, which swimmer will be for each stroke. So these are the decision variables. We need to decide whether the swimmer here will be in charge of butterfly or backstroke or freestyle. Okay. So we'll just expand this table a little bit to include the results, constraint, and condition. So we'll just create a table for this. A little bit bigger. similar to what we have just done in our previous, lab. And it just has something like this. So the result here is that, okay, we will just, denote that, okay, 0 here means that, no participation. No, the decision variable here can only take the value of 0 or 1. 0 means that, the person will not participate in the stroke, and 1 means that, he or she will be in charge of the stroke. So no here, we just say that, okay, no here is for 0 is for no participation, and 1 here will be for participation. Okay. So basically, we want these values over here to be either 1 or 0. Okay. And that's why we call for the optimization modeling with binary variable, either 0 or 1. The results here will just sum. We'll just take the sum of all of this, just like before. Okay. And the sum here represent that for the constraint here, it should be equal to, just set this one equal to 1. Okay. So what does it mean by the constraint here? It just means that when I take the sum of all of this, it should be equal to 1. And the variable here can only take the value of 0 or 1. So thought here can only participate in one stroke only. Okay? Because the value can only be 0 or 1. And the sum of all of these values must be equal to 1. So it just means that thought here can only be in charge of one stroke only. Right, so that is the first constraint. We can just summarize our constraint here in this section. So the first constraint here is that each swimmer is in charge of only one stroke. So that is the first constraint, and it will be satisfied by this condition here. It can be either 0 or 1, and because the sum of these values must be equal to 1, so there will be only one situation when 1 occurs here, and the remaining must be equal to 0. Okay. And similarly, we'll just do the same for each of the swimmer here. We'll just take the results here equal to 0, the sum here, and the constraint here is the same. All of the constraint here is the same. Alright, so that is the condition, take the constraint, the first constraint. The second constraint here is that each stroke here will be only in charge of one person, a separate person. Because for example, we cannot have like the butterfly is to be dealt with by both swimmer. We only need one swimmer for each of this. So this one here means that one stroke has only one swimmer. You cannot have like two swimmer to be in charge of one stroke. Okay. So again, we'll just take summary of this one, and we will just set it equal to 1. So each of this stroke here will have one person to be in charge of. Okay. Right. And we can just use the auto sum here, just like last week. So we can just use the auto sum here, and we can just after we use this, we just double check whether it's calculating the sum correctly, just to make sure. Okay. So this is our first constraint, our second constraint. Now the third constraint here is that our decision variable have to be binary. So it can only take the value of 0 or 1. constraint here, and that's it. Now we need to design our objective. So for the objective here, we'll just calculate the time it takes for all of these trees for a swimmer to finish all the stroke. So we'll just take the sum product. The sum product of the times it takes for each swimmer to finish the stroke, and multiply with whether they actually participate in the stroke or not. So for example, if thought participate in butterfly, so butterfly here will be equal to 1, and for all other stroke it will be 0. So thought will just it takes thought 38 seconds to finish the butterfly stroke. So 38 here will be carried into our total time here. Okay. So we just take the sum product of the time it takes for the swimmer to finish the stroke here, multiply with whether they actually participate in the stroke or not. And the answer here. And this is our objective. And for this one here, we want to minimize the times. Okay. So we'll just go to layer. Again, we do not have solver, so we have to install it again. Yeah, click on solver, and we want to minimize the time here, so we click on the times minimum value by changing the values here, our decision variables. And we'll just add some constraint here. The first constraint is this, equal this section. The next constraint is this one, equal 1. And the last constraint here is that all the decision variable here must be binary. So we click on binary here. Okay, binary. Click OK. And after we have already specified all of these variables here, we'll just choose the nonlinear model. Now the reason why we choose the nonlinear model here is because we have to choose for each swimmer there is only one and only one stroke, so it cannot be a linear model here. A linear model here should be something like our previous example in our previous lab, where we actually draw a line from each destination to from each origins to each destination. But in this situation here, we have a non-linear model, so we'll just click on solve here, and so we have the results here. So for example, here in this situation, Todd will be in charge of backstroke, Bessie will be in charge of freestyle, Lee will be in charge of breaststroke, and Colleen will be in charge of butterfly. And the total time for this should be this values over here. Okay, we have just give the solution here, or we can have some kind of report. If you want to have some kind of report here, just click on this one, outline report, and click. Okay. And sometimes you just if you want to have the scenarios, you just click on scenario name here. Okay. Right, so here we have the solution for this. And as for question 2, it said that if top here the time it takes for him to finish the backstroke here is not 44 seconds anymore, but it's 46 seconds. Then should the coach be concerned about this inconsistency? So it will be quite simple. We'll just copy everything here. I just copy this. Just rename this one to activity 1A, and I will just paste everything here. And I rename this one here to activity 1B. And instead of having 44 here, we'll just put 46 here. And we'll just do the same. I will just put everything back to 0 here. Everything is just the same. We'll just double check the values a little bit. And here we'll just set the values here, minimum value. And we will do the same as before. Except now the backstroke here is 46 instead of 44. Binary. The results here equal 1. And this one here equal this. And we click on solve. Okay. So you will see from here that originally, if the time finish, toss finish, the backstroke is 44 seconds, then top will be in charge of backstroke. But if it changes to 46 seconds, then top will be no longer in charge of backstroke. They will be in charge of freestyle. So obviously, if there is any consistency in the performance of one swimmer, then the choice of the assignment of each swimmer to each swimmer will be totally different. And in this case here, the coach should be very concerned with the inconsistency, because everything changes to when anything changes in the time taken to finish each of the stroke here, then the assignment of each swimmer will be will totally change. Okay. So that is how we do it, activity number 1. So I just leave you to it, and please also do activity number 2. Okay.